All right, we're live. So we're gonna finish up where we started yesterday on doing my first Blender patch. We want to kind of review the code that Claude came up with, polish it, and kind of get it ready for the pull request process. I feel like we had a couple issues yesterday with the stream. Had the wrong album art on the video, and then I think the resolution of going to 125% was kind of small to watch on a mobile phone. So the GNOME 49 doesn't let you pick 150%, which was the old scale that we used to do. So I think now it's like 166 or something like that. So hopefully that'll make it a little easier to read on the screen. So I think today is going to just be us getting a better understanding for Blender's code base, how it does things, maybe getting a little bit more brushed up on C++, which I'm pretty rusty on. I haven't done in a really long time. Today I'm going to play an album from Haunt Dreamers, Transylvanian Records on Bandcamp. Link is in the description. Go ahead and get that started. Cool. So if we return to my notes, we'll see yesterday an org mode. I recorded that we spent about an hour and 15 minutes on the restore stroke API. So that's pretty good. I realize I have to calculate it, right? There we go, timer 15. Cool. So let's go ahead and log back in. Oops. Cool. We're logged back in here. So now org mode will start documenting how much time we're spending on this project. And let's go back to Blender. By the way, I think I managed to get Blender looking okay at this high of a scale. It's pretty readable, I think. At the same time, it's still big enough that I can kind of read and see what's going on, so that's good. All right. Okay, so we're gonna go ahead to Blender get. So one thing we did do yesterday is we created this Python file to test everything. I think it's a little bit robust for what it is. We probably have to cut this down. And with the pull request, we'll send out a cleaner version of this, a little bit more tight. Because I think it's a little bit complicated for what it is. I mean, it's like 368 lines for a test. Which, I mean, not unheard of for tests, but I think it's a little on the excessive side. Alrighty, so let's go ahead and use Maggot, and we're gonna go ahead and now see what are the state changes. So as you can see here, these are my Nix flake changes. We're not gonna commit these. These are just so I can have a Nix environment where I can type in Nix develop and all the Blender environment is set up for me to build and run Blender. So interestingly enough, yesterday, almost everything was created in a single file. So what we're really going to do is we're going to review that this all kind of makes sense in the context of Blender. And just to pull this up again, we were doing this work is for annotation. So as you can see here, I can draw an annotation. What we want to be able to do is programmatically draw annotations using the Python API. This used to exist for Blender, but it was since removed. So we're going to want to re-add it back. And in fact, we did find where in Blender that this code used to exist. So maybe I can pull that back up. Bookmarks. See if I can find the history. All right, we'll look for that later. It's not as important because we're starting brand new, right? Okay, cool. So let's go ahead and review the code and kind of get a sense for what's going on. So I think all of this until the annotation layer new, which is a creation, should be fine. Okay. A lot of the stuff here just seems to be setup code. Okay, cool. So we're going to keep going until an RNA annotation layer new. Okay, cool. Not sure if Negate is doing this in a weird index. Yeah, it's a why is it buffer only? It should be able to allow me to okay, let's just do our annotations. Cool. And to let's also review the ticket that we were working on real quick. We did put it in the description. Let's see. The issue is this. Cool. So we're reintroducing strokes points API, annotation strokes new, and remove stroke. And then there's annotation stroke points, add and remove, and the arguments they had. I commented yesterday that I was gotten alpha on this working. So the next week, polishing into a PR. And Falk David, I guess, his username is file descriptor, gave me a thumbs up on that. Okay. So let's go ahead and first function we're going to look at is RNA annotation stroke new, RNA annotation stroke new. Cool. Then we're going to go down from there for a bit. 1 second. Okay, there we go. Cool. Awesome. All right, let's start reviewing code. So we go ahead and we do a calloc for that allocates it in memory using a calloc for the type annotation stroke. And we go ahead and initialize that stroke with default settings. I wonder if these default settings are correct, and if so, because if you look at how they worded this, they basically said only pass in new. They didn't say that we were passing in anything sophisticated here. So do I just default to these settings? And if so, where are the locations of these defaults? Like, is there a specific place that creates it, or are we doing that manually every time? So let's go ahead and look through the code base for some of this. GP stroke 3D space, that looks like something that would maybe be part of an instantiation process somewhere else. It seems to me, looking at this code base, that they don't necessarily have this place that they instantiate these sensible defaults. That could very well be something that maybe we take on another project where we go, how do we instantiate these defaults in a way that's not being instantiated several times over, because like, why these defaults over any other defaults? Like, I wish somebody had selected sane ones. So we will, I'll leave a comment in the code for this. Okay, make stroke, rotate with viewport, like no normal annotations. We can remove that. So these are just the defaults. We add the tails, so we get the frames and the strokes of that frame, which is usually like an array essentially. And then we go ahead and add to the tail, that's the end, the stroke. Out of curiosity, can I see where this bad boy is defined? Cool. So this gets a list space, and this goes ahead and just adds it. So link equals null pointer, return, of course. Link next, null pointer. So we create that link. Now you're passing a void. Okay. And then you make the previous one the list space. Oh, this is like a linked list, right? You got the next and the previous. So that's cool. List space last, next link. Okay, that makes sense. List space first equals a null pointer. List space first equals link. Okay, so there's nothing in that list space. Go ahead and set this up. Okay, that makes complete perfect sense. I think we're in a good spot there. Now RNA stroke remove. And let's review the pass for that. You just pass in a stroke and it should be able to remove it. So nothing too crazy there. Cool. So we go ahead and we statically pass that stroke. We look to see if you can find index, if the stroke exists in framed strokes. If it doesn't, that returns -1, stroke not found in annotation frame. Perfect. At that point, we go ahead from the address. Okay, we get the address, you get strokes, and we remove stroke. We then, once we remove the link, we also free the stroke, and then we invalidate the stroke pointer. And let me see. Okay. Make the pointer valid. It's especially pointed for the Python API as any access to a valid pointer RNA should raise an exception in BPY code. Okay. That's the thing word. Okay, cool. And then we go ahead and we add notifier pencil, edited, null pointer. Interesting. Let me double check what this function does. Did this have a notifier? This also had a notifier, so let's see what these notifiers are doing. So you go ahead and get object window manager, static passive window manager, and UW event add notifier. Let's look at this bad boy. If the window manager is a null pointer, return chorus, WM event add notifier intern. I think going down the rabbit hole, huh? Okay. Note test category. Look here, once again, they're just kind of instantiating this with a bunch of data ad hoc, as opposed to maybe using some kind of builder pattern or something. Cool. I'm going to just see if I can pull up some documentation about that function. WM main add notifier. Let's see if we can pull up some documentation, because it'd be kind of cool to see what Blender says about that in general. Unfortunately, it's an internal function, so there's no other documentations other than like a post here. Okay, that's fine. I think we can accept this at face value for what it is. Cool. So we did annotation. Oops. Cool. So we looked at new and remove stroke. They both are fine. Now we're going to get into annotation, stroke count, radius, opacity, and that one's a little bit more complicated. One thing is, I wonder if this is the actual style you're supposed to be doing, because it seems a little bit weird. Yeah, no, annotation frame remove does something similar, and that's not a function I wrote. It's kind of weird, but who am I to judge this? Awesome. Go ahead and create a new pointer, new points. If the count is less than or equal to 0, return, makes sense. Stroke points, you do a static cast, you do a the memory allocation for stroke points. The size of the GVDS2 point. Sense times the count stroke taught points. Okay, see what it's doing there. So it's trying to just allocate the right size of memory. So I think the question is this the correct way? It looks on surface the correct way, right? Because it would be new points. And it would be times the Todd is total points, right? Okay, so what it's doing here is you get the total amount of points that already exist. And then we add count, which is the addition, right? The amount that we're adding to this. And then we multiply it by the size of each of those points, which we know from this pointer, right? We can go ahead and get the size of this bad boy. And then we can go ahead and do that. I wonder if that's kind of a canonical way to do this, is to declare this and get a size of. Like, it almost seems like you're kind of implying that, do you not know that till runtime? I just wonder if we couldn't get that point permanently, if this is like the most canonical way to do it. You know what we can do is, let's find out. Let's see how else they use size of in the code base, and then they actually just are doing that on straight up, hey, we're going to declare this pointer, and then we're going to go ahead and just declare that pointer just to get the size of it. It seems kind of unusual. Yeah, look, here it does size of scalar. So I wonder if I couldn't just do... Oh, never mind, I misread this. This is actually going straight for the type. It's not actually getting it from the new point, so that's fine. We're going to have to probably use new points for something else, so I don't think that is the end of the world. Cool. So then we go ahead and we use new points, and then we say stroke points get total points. That's interesting, because that'll always be the end, right? So if you have one, the index of the actual one would be 0, because we're off by 1. So that is an interesting way to go ahead and set this up. Okay. Now we're going to go ahead and loop, initialize the new points with new values, and then we set its default values again. What I don't get is why XYZ is 0. It's just an initialization, so maybe we set things up later, but at what point do we set things up later, you know? Maybe I'm not understanding the API completely. Overall, this looks good. I'm just once again kind of befuddled about how little information we're passing to these functions and how that reflects broader ideas of the API. Let's go ahead on to RNA stroke point remove, and that's this over here. So if the index is less than 0 or greater than or equal to the actual amount of points, point index is out of range. That's fine. That makes sense. Cool. So we get to ship all points after the remove point, right? So we take the index, just the one we're removing, and let me just look at mem_move real quick so to refresh my memory of what that API looks like. Okay, cool. Copy n bytes of source to dest, guaranteeing correct behavior for overlapping strings. Source is the second one, interestingly enough. Okay, so that's the destination, right? And that destination is what we're deleting. So we go ahead and the dest and source, right? Yes. This is a dest. This is destination. This is the source. The source is what's afterwards. So we go ahead and move that, and let me see how that size of stuff works. Size T. Let me pull up some actual documentation on mem_move just to make sure I'm understanding this correctly. Okay, understand that. Count number of bytes to copy. Cool. Just double checking. And we know that that's the number of to copy because if you take the amount of total points minus the index minus 1. That part I don't get. Oh, because the stroke has a total amount of points, right? And if you take that total amount of points, you take the index, which is, you know, the addition, to get the gap there, and minus 1. Well, there'll definitely be one there in there less now, right? I think that makes sense. And then afterwards, they do a stroke total points -1, so there's going to be a 1 less total points. So stroke total points -1. Interesting enough, we do that here, but okay, we do the stroke points -1, then we also minus the index. Cool. So if the stroke total points is greater than 0, stroke points, you do a cast. You do a GPD point, you allocate that. Cool. memory reallocate to that new size, right? You have stroke points, and now you reallocate to the new total points times that. Okay, that makes perfect sense. And then you do a memsave free if it's not greater than 0. Okay. I wonder if that creates any problems. For instance, if somebody wants to look for stroke points and doesn't find anything. Let me just double check memsave free to understand that implementation better, so we're not doing anything crazy. But I'm guessing it just makes it null. Just in case I want to make sure there's nothing else here. Okay, this is just a Blender thing, so I'm not going to worry about it on a C++ level. Cool. And we add another notifier. That is cool. Let's go ahead and just double check where we are on this. Rotation point remove. Cool, and then we have a bunch of declarations, which aren't as big of a deal, and then the API stuff. Okay, we'll go by those one by one to review that. Okay, cool. I think we're mostly in a good spot here. What are we doing? So let's do the 4 declarations. Stroke API, stroke points. Do I need 4 declarations like that? We just double check 4 declarations, C++. The existence identifier before this allows the compiler to understand the name and the valid type or function if it doesn't yet know the details of the structure implementation. Reducing the amount of compilation time, reduce coupling. Okay. We'll see if we can get away with removing this, but I'm guessing it's here for a reason. Cool. So we added 2 4 declarations. Out of curiosity, are there 4 declarations anywhere else? I really don't see any. Okay, we'll let's try to comment these out and see if we get away with it. Okay, cool. So the next part is we go ahead and added these 2 blocks of code, and that defines property pressure. Why did we add this? Why did the LLM add this? This is... Oh, you know what? I think pressure and strength didn't exist. Pressure, not a tablet, a point, drawing it, color intensity, data point for freehand stroke. Okay, I think these didn't exist before, that's why. And then at the very end, okay, see, it does actually at some point need those static declarations, so let's go ahead and do that. One thing is this isn't the correct capitalization, so maybe what we want to do is we're going to replace that. So RNA def annotation stroke points API. Let's make this all capital. Right? Should always be all capital. I think. Actually, I don't know. It looks like it, right? Yeah, I think it's supposed to all be capitalized. Okay, so we're all good there. Okay, so let's go ahead and look for this again. Okay, so this looks good. This is now up to snuff here. I guess you declare APIs here along with properties, collections, things like that. Cool, same thing here. RNA, def, annotation, strokes API. We do. Cool. The RNA def strokes API, cool. So that's good. Stroke points API. Did I miss something? Stroke points API and then strokes API. Okay, cool. Got those both modified. Okay, we got two big functions still ahead of us. And this is our RNA def annotation strokes API. Okay, annotation strokes API. And then I think that's good. Annotation strokes API and RNA def annotation strokes API. Why do these look so familiar? Functions look the same. What's different? Seems there's arguments they're passing in. We have stroke and stroke points API. Okay, cool. That should be fine. So let's go ahead and read these. We go ahead and create a struct RNA function, RNA function, RNA, and then we do RNA def property. So I guess when you create this API, you go ahead and you create a lot of annotations, or sorry, a lot of like types manually, like annotation, strokes. Maybe this is how the API self-documents itself. So So we create, add a new annotation stroke, a pointer, annotation stroke, the newly created stroke, the return. Okay, I think this all makes sense. Let's start looking into running the test suite. Blender run test suite. Okay, CD Blender make test. Let's go ahead. Okay, we have Blender running, that's fine. Let's do Nix develop. We'll do a make test, and then we'll add some new tests too for this API. Alright, so let's go to CD Blender get one. Okay, everything is failing, that's not a good idea. Okay. Hey? Why would everything fail? Guessing my environment is not set up for this. So let me go to the build directory and see if we can just do a C test. Apparently that's a more fine-grained way of doing this. CD Blender. Oops. Let's see. Build Linux, I think. You can say if those tests failed or succeeded, did it? List available tests, I see. Let's do J16. Okay, this is also failing. Okay, we might call on Claude to see if we can get these to work. All the changes I think we like. Let me see what minor changes we made. We just removed some comments. We renamed these to be a little bit more consistent with the capital R and A. I think, yeah, we just made a couple of small changes. So I think for the most part, Claude did a good job. We'll keep these changes staged in case Claude messes something up. Okay, let's see. Claude. Get make test to work in the Blender Git directory. This may or may not involve some Nix changes, right? Because Nix sets up my dev and runtime environment. So it sounds like it looked like from those tests that it wasn't able to find some of the stuff it was looking for to run. So we'll have to work on that. And I don't know if we ran this at all today. Let's go and run this real quick. So if I hit, God, it's so small. Okay, there we go. Play. There you go. See, we got all this stuff now. Pretty cool, right? See, Claude, yes, and don't run it. Ask again for make test. While Claude's doing that, I wonder if I can make a simpler test file. Yes, and please don't ask for echo commands. Yes, we may have to do that a couple times with Claude. Okay, let's do. Annotation, simple annotation test.py. Cool. Let's simplify this a little bit easier. We'll remove this and we'll just make this part of the instructions. Okay, cool. Wants to test Blender directory. Maybe this will close it just in case it needs to kind of run into stuff. Okay. The annotation data we've seen. I'm gonna need to comment on this. We needed to print all this stuff. Just need to raise a runtime error, find annotation. Okay, cool. That should be good enough. Let's clean this up as we go. this. Not frame. And I'm allowed to make some edits. Gosh, I'm afraid of it. Let me copy my previous flake to flake.backup just in case Claude messes this up. Cool. So that's simplified. Let's do that here. What are we doing here? Let's see, remove. Claude, what do you need? Claude, reconfigure. Claude wants to do a make. Let Claude do a make. I think this test is overall way too complicated for a PR. I'm not gonna do this one. I don't really like this one. I like test stroke operations. Oh, well, we gotta do both. So never mind. Whatever. I think we're definitely removing the complex drawing one. Let me see. Meow should be able to do a defun, right? Cool. I think we got this way simpler now. So now they can probably easily read this and kind of know what's going on. Before it was like really complicated. I think we really don't need to see that much. I don't even know how this got here. Deleted. Cool. This is a way cleaner file we can send over to the code review, and that'll be a nicer way to test. Let's see how Claude's doing setting up my test environment to write some tests. Looks like it's still fixing next. Oh, but look, it just finished building, so it's good. You know, I'm gonna have to close all these bad boys and recreate, because we have a new Nix file now that has a new dev environment and a new build environment. Cool. Let's see what's Claude's been up to in general. Oh, jeez. Deleted it? What is this? Why would you delete my flake.mix? They probably restaged my latest changes because you have to stage them for Claude not to, or sorry, for Nix not to freak out. Okay. That's funny, why would we not stage that? I think this was a fairly non-controversial pull request. I think now we just want to update the tests, and as well as, I think updating tests is the real thing left. Let me go ahead and make sure I'm all set up for that pull request. I think I need to fork Blender into my own repo and all that fun stuff, so let's do that while Claude figures things out. Alright, Claude is still working. Let's go ahead and get stuff ready. Get remote, add in 0. Added my remote, remote V. Cool. We've got, oh, that's funny. Yeah, I guess it doesn't matter if it's HTTPS or not. I actually managed to put a dot in my username. It doesn't matter, I like it like that, but I don't know if that's going to create a problem for anyone else. Okay, it's related to my Blender ID name, I don't care. I like that actually. Cool. Bot is still working. see where else. Okay, pressure and strength are there. Let's see. So part of the documentation process, declare them where we did. Cool, looks like we're almost done with the make test stuff. And we can go ahead and see about adding those tests for the code that we produced yesterday. Alright, fingers crossed to make tests work and we can move on. How much resources everything's taking up out of curiosity. Let's see. Funny enough, GNOME does tax the GPU a little bit. It's actually, I think mine is running on Vulkan last I checked. This makes tests for taking forever. Oh, interesting. They got like a little Kanban board here. That's on that to-do list, so glad I could be of some help. Wonder what other tickets we can take a look at maybe while we wait. So I was over at this Blender introduction for new users, or new developers rather. So you can go to pick a project, list of good first issues. Fuzzy search one that just came up. I think someone grabbed that one real quick. That one's not the hardest thing, right? This one's interesting. Bump up AOV to 64. Current limit is 16. Rapidly limiting NPR setups. I really have to do a lot of research because I don't quite know what all of this means. But sounds interesting. Okay, I hear the CPU running. Let's see if there's been any updates. I'm guessing it's running make test again. I wonder how long that test suite takes. Anti-aliasing on normal lines. Kind of crazy that one's been open for like 2 years. This guy abandoned it after a year. Wonder what the feedback on that PR was that he didn't really bring it across the finish line. Geometry shaders are unsupported by the metal backend. Alternative implementation is required utilizing a vertex pool solution. Same pattern already exists for a number of shaders 3D polyline. The general idea is the fragment shader vertex interface from exactly the same, but instead multiple instances of vertex shader involved per input vertex to allow a greater number of outputs. Okay. 3 months ago, well, last year, they responded and nothing happened. My CPU sounds quiet. Nope. CPU is still working on a make test. I think the delay is just really long, and the timeout's maybe 10 minutes. That could be a while. Control O to expand. Okay, looks like 89% of tests passed, 59 tests failed out of 531. It's not ideal. Python. Okay. I'm wondering, I probably want all the tests to pass. I don't know if I want to hold everything up on that. Maybe I'll have to, I don't want to spend all the time trying to fix the test environment. Okay, let me see how it works now, and then I might call it early and fix my test environment later, because I didn't realize I could have the build environment work without the test environment, so I want to fix that ideally. The next develop. Can't type right now. develop takes so long. Sweet. Blender get. Make test. Okay, so it looks like this test running portion, actually, I know what I did wrong. I didn't let them run in parallel. Let me try to parallelize it. We also have to do a time to see. Okay, it seems like it's gonna take a really long time. I don't know if it's a worthwhile use of time just to watch it test. Okay, cool. You know what? Let's go ahead and call it. I think we are in a good spot to go ahead and release, set up a PR soon. So this code's all fine. We reviewed every single line of it. It looks good. It matches what the rest of the program is doing. So what I'm going to do is I'm going to work with Claude to come up with some automated test to prove it works. We did already do a simple annotation test. We cleaned that up today, so that one will be pretty easy for someone to review and just test out. It's not as complicated as the one Claude came up with. So I think I'll go ahead and probably do the rest of this off a stream, and then we will find some other project to do. I'm thinking maybe we could do a Lispy project, because I have a lot of requests right now to go ahead and get Claude, or what's it called? Closure TS working. Right now, Closure TS doesn't work, and it's not clear why. So we're going to go ahead and have to figure that out. So that might take a few sessions. That maybe that'll be a little bit more interesting than some of this more esoteric 3D stuff where, you know, we're going a little bit at a slower pace, although it is pretty fun, for me at least. So I think we'll probably do another Blender ticket next month in December, but I think I'll take a break and go back to Emacs and do at least a couple of Emacs streams before we hop back into Blender. As far as GNOME, I'm not sure what we want to do in GNOME yet. I went through a few projects like GIMP and GNOME Music and Fractal, and I don't know, I didn't see any really cool tickets there. Oddly enough, I thought the Blender one seemed more interesting and accessible than the tickets I was seeing in GNOME. Maybe because GNOME is such a simple piece of software that's like, it's stable, it's simple, there's like not really much to do there. Maybe we could write tests for some of these GNOME applications. I have never written a test for a GTK4 application, so that might be fun. We'll figure it out. I kind of am feeling pretty intrigued by Blender and would like to spend a little bit more time learning how to use it and coding for it and writing patches for it. So I think that would be a pretty cool use of December. But I think we'll get back to a couple of Emacs streams before we do another Blender stream, just to mix it up a little bit, especially since a little bit more on the Emacs and Emacs list than I am at Blender and C++. Although I think, you know, given I think we spent, let's go and clock out right now. We didn't really spend that much time on this project, right? So let me do a clock out. Cool. And if I do this, okay. So far, we spent basically 2 hours. I just spent 2 hours offline off the stream, getting to compile, and it's actually kind of hard on Nix. And in fact, a lot of the bugs I'm seeing right now on the compilation are related to the fact that Nix is just not easy to work with for Blender. That might also be an obvious thing for me to work on too, is improving Nix support for Blender, because Blender just assumes a lot of stereotypical Linuxy locations for things, which isn't the case for Nix. So I might need to fix that, or at the very least, some of the Nix developed files I've developed to create this reusable environment for Blender development on Nix. Maybe I need to upload that somewhere and kind of get that a little bit more out there, as opposed to just being on my machine, because I'm sure I'm not the only person who wants to develop Blender on Nix. Okay, cool, we're almost done with those tests, but yeah, this is going to be way too long to run all these tests for every single change I want to try to make. So I'll do that later. But yeah, overall, I think we had a pretty productive 4-hour project in general, so no regrets there. And yeah, we'll call the stream for now, and we will start up later. See you all next week. Bye.